Hello, my name is Reef Kassam, and welcome to our webinar, Introduction to NuoDB. I am the VP of Products here at NuoDB, and in this monthly webinar, we will be introducing the benefits and high-level architecture of NuoDB's Elastic SQL databases, as well as provide a brief demonstration on how easy it is to deploy and use NuoDB. At the end of the webinar, we will open it up for Q&A. Before we start, a few logistics. The webinar should last about 30 to 45 minutes. The webinar will be recorded and will be available for replay. Attendees will be muted during the call. However, you may submit your questions at any time during the presentation using the question box in the GoToWebinar control panel. And with that, let's get started. So NuoDB is what we refer to as an Elastic SQL database. And what we mean by that is NuoDB combines the simplicity, scale out, and elasticity and continuous availability that cloud applications use and need with the transactional consistency and durability of standard SQL databases of record. We try to combine the benefits of a traditional SQL database with some of the scalability and availability benefits of some newer database architectures. So let's sort of walk through why NuoDB works in today's architectures, right? So traditionally, as everyone knows, both infrastructure and technologies are changing rapidly. Back in 30 years ago, obviously there was mainframes, client servers, and scale out. The application architectures in these environments has changed significantly. You have a lot more distributed data applications running across multiple servers. However, the database in these architectures has remained relatively stagnant. Typically a single server with multiple disks. Some databases have the ability to cluster the database for availability reasons, but generally from a scale out perspective, it is a single database server that is a single point of performance and availability restrictions. So what are our customers asking for? Our customers are asking for a database that is native for clouds. So everybody wants an elastic database that allows them to run the database in a virtual environment on commodity or cloud architectures. They want to meet the architectures that are being used today, which allows for elastic scale out and scale in, as well as the ability to have something continuously available. In cloud environments or in some of the newer architectures, it is common for servers to go down, right? The built-in redundancy into the cloud allows for the use of commodity servers. And so what you need in the cloud environment also is required from a continuous availability perspective. However, a lot of companies have invested a lot of money into their SQL database. Their applications are built on top of the need for ACID semantics, so the ability to have consistency and durability, the ability to reuse existing SQL architectures, SQL code, SQL applications without having to rewrite it for another architecture. And then the SQL abstraction allows applications to push some of the logic down into the data management layer rather than building it up at the application code. And so what our customers are commonly asking for is the ability to elastically scale a SQL database on a cloud environment. So at a high level, as I mentioned earlier, the benefits of Elastic SQL is the combination of the traditional SQL databases, such as Oracle, SQL Server, DB2, with its ACID consistency, SQL logic, and abstraction, with the Elastic scale-out, virtualization, commodity cloud architectures, and zero downtime that some of the NoSQL vendors provide. And today there's this market gap, right? The market gap where you have to choose one or the other. You either have to continue with your existing SQL database and try to accommodate the new architectures, or rewrite your application to work with the semantics of a NoSQL system. So this market gap is obviously what we think is the emergence of an elastic SQL capability, right? So these are the capabilities that combine both the capabilities of a traditional database as well as the capabilities of a NoSQL database. And we refer to that as the elastic SQL market. We are not the only ones that are in this space. We probably started this space a long time ago, back in 2010. But both Google, Cockroach, and Amazon have now started coming into this space, and that's sort of a vindication of our pioneering efforts in this space. Previously, people were saying, "Well, why do you need this elastic SQL capabilities?" Because we have NoSQL. Well, some of these other larger vendors are now telling their consumers that yes, you still need the SQL semantics, you still need SQL ACID guarantees, you still need the ability to have data in a relational form or in a schema, right? So Google Cloud Spanner announced their platform probably about 6 months ago now, maybe a little bit more. Cockroach Labs, which is an open source version, also came out about that same time. And then late last year, Amazon Aurora announced their multi-master capability. So while this space is relatively new, there is a lot of interest, and there's a lot of work going on by both large and small companies to provide solutions in this space. You as a customer have a lot of choice in selecting databases. It is actually quite daunting in selecting which database to use in what situation. This is a bit of an eye chart, but hopefully it shows you the different decision points you have on selecting database. So just to orient you on this diagram, from a column perspective at the top, you have your traditional databases, which also includes databases as a service. You have your NoSQL vendors, and then you've got the various elastic SQL vendors. And then the rows are split out into sort of SQL capabilities, cloud requirements, and other use cases. So top of mind for a lot of customers is, can I take my existing SQL application and migrate it to one of these vendors? From a cloud deployment, it's all about elastic scale-out, active-active, the ability to have multiple writers and multiple readers working concurrently across different nodes. Can I have a flexible deployment in different cloud architectures? Does it support microservices? And then in other use cases, there's just general non-relational data, streaming IoT, and in general analytical queries. So just sort of going through this chart quickly, obviously the traditional SQL databases are great at SQL. They have a partial check mark on migrating. As everyone knows, migrating a SQL database from one database to another is generally not an easy task. There is work to be done. And so it's not a drop-in replacement. So it's always some work to migrate from one SQL to another SQL. But in general, the rest of their capabilities are fairly lacking, both in cloud and some of the other use cases. Database as a service gets better because you are abstracting away the scalability. A lot of database as a service vendors, the way they do the scalability is in the background, they lift and shift your database from a small server to a bigger server. It's still a scale-up architecture to address scalability, but it's sort of hidden from a customer. So in that sense, it might be fine. The NoSQL vendors have a great capability in elastic SQL, active-active, microservices, other use cases. There's a ton of vendors out there you can choose and pick a NoSQL database for your use cases. However, one of the big issues with NoSQL databases is the need to re-architect the application for the NoSQL way of data management. You've got to incur a lot of application overhead in managing what was traditionally done from a data management perspective, was traditionally done in a SQL database, a relational database, is now put into the onus on the application side. So there's a lot of rework done on migrating SQL applications. And then from Elastic SQL, you have Google Cloud Spanner, Cockroach, Aurora, and NuoDB. I'm not going to go through the different check marks and X's, but in general, with Google and Amazon, you are locked into their platform. So you are limited to using the database in their environments, and that's fine if that's the cloud platform that you choose, but it makes migrating between cloud platforms hard. Also, Google Cloud Spanner and Cockroach support SQL queries, but they don't support SQL writes. So updates, inserts, and deletes have to be done through an API call. So that makes it harder to migrate a SQL application. And then in terms of flexible cloud deployments, one of the big benefits of going with third parties like NuoDB is that we can support multiple cloud platforms. So we can run NuoDB across both Google Cloud, Amazon, as well as Azure, Microsoft Azure, right? So you're not locked into a specific vendor, and you can also support availability outages across any one vendor. So just a quick overview of a couple of our customers using NuoDB and why they're using NuoDB. So the first customer we're going to go through is Dassault Systems. Dassault Systems is the largest software company in Europe after SAP. They are a PLM CAD/CAM system, so large manufacturers like Boeing, car manufacturers use Dassault Systems software to engineer their components and their products. They have traditionally been an on-premises software vendor, so they had software that would sell to customers, and customers would then deploy it on their own premises with a database of their choice. As software vendors, Dassault Systems has migrated to the cloud and offering their systems or their applications in a SaaS offering, software as a service. And so as part of the migration to that offering, they wanted to consolidate their product portfolio along with the database that can be used in the new cloud environment. And so they selected NuoDB because we were built natively for cloud environments. We allow them from a continuous availability and the ability to elastically scale as demand grows in their customer environment. From a benefit perspective, there was a significant cost savings over Oracle, and in their environment, the data layer becomes a competitive advantage. It allows them to provide different features and functionality within their application layer to take advantage of the cloud architecture that is provided through a NuoDB data management system. The second company is Move Medical. Move Medical is a much smaller startup. They were also, so they provide a software solution to manage medical devices and case management for the medical industry. And like Dassault, they had an on-premises solution, and they were also moving to a SaaS or cloud offering. And in their case, being a startup, their offering, they were unclear as to how much traction they would get in their cloud platform. So they needed a solution that would allow them, they needed a data management solution that would allow them to grow over time as their demand growed. Without sort of that capability, without that scale out capability, a lot of cloud providers or a lot of application providers in the cloud over-engineer the data management layer just in case there was a spike of usage and demand in that cloud, since they can't predict that usage. So they Move Medical selected NuoDB because of its elastic scale out that were memory centric, which improved their performance and continuous availability. Again, this allowed them to reduce TCO compared to Aurora and Oracle at that time, simplify their DR and availability story, and they were able to get to market very quickly. Again, because they didn't have to change a lot of their application code to support a different data management service like a NoSQL service. They were able to take their existing SQL application and easily migrate it to NuoDB into the cloud provided platform. So let's get into some of the details of NuoDB. So at a high level, NuoDB is totally different from your traditional database. Traditional database has a single process that manages both SQL query parsing, optimization, execution, and data storage. So it's basically a single engine that runs on a server that manages that entire stack. What's different about NuoDB is that we've split the traditional data management architecture into two separate services. We have what we call our transaction engine, which is our transaction processing service. This is a fully in-memory, fully redundant layer that allows customers to scale out their transaction processing across multiple nodes. You can think of it as an in-memory grid of data cache that supports the SQL semantics completely. The second layer is our storage layer, right? So we've split out the storage management from the transaction processing. And this can also be distributed across multiple servers and across multiple services. You could have multiple copies, fully redundant copies across multiple servers, or you could have the data partitioned across multiple servers for better I/O. Having two independently scalable services allows customers to mix and match and adjust their deployment topologies based on their exact workload. If they have a huge write workload, they can scale out at the data management layer or at the data storage layer, the storage managers, or if they've got a lot of read access, they can scale out at the TE or the transaction layer and scale out their system. From the perspective of an application, all these processes work together and look like a single logical database. The application is really unaware of the fact that there could be multiple nodes processing the data, that there could be on different systems or in different data centers or availability zones. Again, from an application perspective, it doesn't really matter. It doesn't really matter how the database is deployed across a cluster or a set of clusters. It's just that within NuoDB, it looks like a single logical database, and we manage both the asset semantics and the durability guarantees for the application. What makes NuoDB unique is what we call our durable distributed cache, right? So we talked about the transaction engines being fully in memory. This allows us to put the transaction services very close to the application. Again, if you think of it as an application in-memory grid, if you will, that supports the SQL semantics and the management of persistence of that data. So in traditional application caches, you've got to figure out how to manage your writes. You write to the cache and write to the database, or have some other sort of write beside or write through cache strategies. With NuoDB, that cache is integrated with our storage manager, right? So you don't have to worry about managing the synchronization of the cache as well as the storage layer. The cache is fully distributed. Each of the TEs has its own cache. That cache is automatically built up based on workloads that is directed to it from the application. So if you've got 5 TEs, we're not saying that you have to partition your data across those 5 TEs identically. So the data across those 5 TEs could be completely independent, or there could be any part of overlap of data across those nodes. And obviously, the durability part of the cache is critical for NuoDB, right? So we're a SQL ACID durable database. That means that when you write through the cache, that write is also made durable on disk in case of any sort of outage scenarios. And so we maintain the synchronization of that cache and the durability of that cache for you, so you don't have to worry about managing 2 different stores. This is a logical view of NuoDB. So at the top, we have standard JDBC or DBC drivers. So again, from an application perspective, it looks like the standard database. The administration layer has a RESTful API to it. Within the database, we've got actually 3 components. We've got the administration layer, which manages the interface to the database. It actually does load balancing, so it provides a way to load balance across all the nodes in the database. And then we've got the database itself, again, composed of the transaction engines, which are effectively stateless, ANSI SQL parsing, optimization, execution, as well as the durable storage layers, storage managers, which could be across multiple nodes as well. We are ACID compliant, as I mentioned before, and we're also MVCC, so multi-version concurrency control. From database perspective, this is sort of a way to improve performance such that readers aren't locked by writers in a traditional locking database. From a network topology perspective, you can sort of think of each of these circles as representing the database process. So we've got the dark green transaction engine processes. You have the light green storage manager processes. These are all distributed across various nodes in the cluster. They're fully connected, so it's a peer-to-peer mesh between the transaction engines and the storage managers. And the application can connect up to any one transaction engine. So what that means is there's no single node that all applications has to connect through. The application can connect up to any one of the transaction engines and start processing and getting data. And again, because it looks like a single logical database, connecting to any one of the transaction engines, the application has access to all of the data. It's not limited to a shard of the data or a partition of the data. TE, the application has access to the entire data set that is stored within the database. So what I'm going to go next is do a quick demo of starting the database, showing how the data is loaded, and sort of showing how the resiliency within NuoDB works. We're gonna emulate a 3-zone availability zone environment. In the first availability zone, there will be a transaction engine and storage manager, as well as an administration process, which controls the load balancing. In the second zone will be a duplicate again. There'll be a transaction engine, a storage manager, and what we call a broker administration process. And in the third availability zone, it's just going to be a transaction engine, right? All these processes will be in Docker containers, and we'll be able to show you how quickly and easy it is to set up and deploy a database, use the database, and then show the resiliency of the database as failures occur. So give me a second while I set this up. Okay, so first of all, let's just do a check, right? So this is basically saying there's no Docker processes running. There's one Docker process running, which is basically my client application, which is this one here, and we'll get to that in a second. What I'm going to do right now is just deploy the engines. So we created a script to deploy all these Docker containers. And so what the script is doing is saying, I'm going to deploy NuoDB. I'm going to create 3 availability zones. In 2 of the availability zones, I'm going to have a TE and SM, and the other one is just a TE. The database is going to be called test. The user is going to be called DBA, and goalie is the password for the DBA. So what's going on right now is we're basically executing Docker run commands to create all these containers. And so in less than a minute, while I've been talking, we've actually created 8 Docker images, right? So the Docker PS shows you there are 3 administration Docker images running, TE and SM running in zone 1, a TE and SM running in zone 2, and then just a TE running in zone 3. And a better way to show this from a NuoDB perspective is a command called show domain summary. So what this is showing you is that actually, while I'm doing this, I'm just going to start. We've created a database. I'm going to start loading the data. While the data is loading, I will explain the show domain command. So what the show domain is showing you is there are 3 administration processes running, admin 1, 2, and 3. these three are connected through a raft protocol. So admin 1 is the leader of the raft protocol. The other two are followers for availability perspectives. The database is comprised of 2 SMs, so 2 storage managers, SM0 and SM2, and 3 transaction engines, TE1, 3, and 4. SM0 and TE1 are in zone 1, SM2 and TE3 are in zone 2, and then as we said before, TE4 is only in zone 3. All these processes are running and available for use. So in this other window, what I've done is just started a load script to load a database into the database that we just created. So it's a simple hockey database. Let me just show you. So this is a DB visualizer window. We're going to connect up to NuoDB using a JDBC driver, right? And we just connected, and you can sort of see here's the hockey database. Again, it's a small database with a few tables. If you go into the table view and you take a look at the teams, what this database contains is all the data from the NHL hockey. So from 1909 all the way through till 2011, every game, every year that was played, statistics of what's collected for each of the players and teams and who's won what. So the point of this is just showing you I'm connecting to a standard JDBC database monitoring or administration tool. This is a DB visualizer. It looks, even though it's a distributed database, this looks and feels just like a single logical database. We have SQL that we can run. So there's a couple of SQL statements here that show you the top goal scorers in a single season. They provide the same information, but it just shows you the different syntax that NuoDB can support. So this is join. This has a where clause. The second one uses joins and different forms of the joins to collect the same data. So what I can do is just run this. And in a couple seconds, you get your output, right? So you can sort of see the top scorers over the years in the NHL. So again, this was just a simple command, simple view of the environment, showing you the database from a standard tooling mechanism. What we're going to do now is going to go through a couple failure and scale out scenarios. So I'm just going to run a simple script, and all this script does is connects up to the database and figures out what TE the connection is done to, and that's all it's doing, just running through that over and over and over again, right? You can imagine your application connecting up to the database in a load balancing fashion. And all it's doing is just executing SQL. In this case, I'm just showing you which TE is connected to. And as you can see, the value changes over time between TE1, TE3, TE4. So again, if you remember our cluster, the transaction engines are TE1, 3, and 4. And so what the script is showing you is I'm just effectively load balancing connections across any one of these transaction engines, and I can access the entire database, right? So let's see what happens when I kill one of these engines, right? So I've again written a script, and I'm going to shut down TE4. So that's gone. So again, if I take a look at Docker, you can see now that there's only 4. There's only 2 TE processes running. TE4 is gone. And again, from a show domain perspective, we only have the SM and TE running in zone 1 and zone 2. The TE in zone 3 is gone. And again, if you take a look at the application, or sort of the pseudo application, it continues to work. Now it's only load balancing between TE1 and TE3. Obviously, TE4 is no longer there, and the application or the sort of this little script doesn't care, right? We just continue to work as if the entire database is still up and running. So let's say now maybe that was an unplanned outage or a planned outage, and I want to bring back that transaction engine. So again, all I need to do is run a simple command, right? In this case, I'm running a NuoDB CMD command, which basically starts a process, which starts up a new Docker image. So now we have TE5, right? And again, from a show domain summary perspective, I now have my third TE, in this case TE5, up in zone 3 again. And again, if you take a look at the client, it's now load balancing between 1, 3, and 5 again, as per normal, right? So I can lose a node, the application continues on normally. I can restart that node or that process, and again, the application continues on. And suppose I want to scale out, I want to add another TE. Again, simple command, start a process, and if I take a look at Docker PS, now I've got TE6. And if I look at show domain, I now have, again, TE6 down here. And if I go through here, you will see it, yeah, there's TE6, right? So now it's load balancing between 4 TEs. So very quick demo. What I wanted to show you was how quickly you can get a NuoDB environment up and running. So with Docker and running a few scripts, I was able to create an environment in less than a minute. We loaded some data into it. It looks like a single logical database. You can use your standard tools to query the database, to look at the database. And then what we did was showed you how the database operated in case of a failure. So we lost a TE. Again, the application continued to connect and load balance across the available TEs. We brought that TE back online. Again, the load balancer said, okay, great, now I can use another TE, and we scaled out. We added a fourth TE. And again, from the application perspective, that is just more resources available for it to use, to access. Single logical database looks and feels just like a single system, but you can scale it in and out dynamically. We went through sort of what is NuoDB, how we're differentiated, the Elastic SQL market, a quick demo of how you can deploy NuoDB as well as operate it in sort of different conditions. So in general, NuoDB, we've been founded in 2010. We've been at this Elastic SQL market for 8 years now. The management team, myself, as well as the investors have been in the database space for a long time. We have people who've done Sybase and others. The application or the system is patented as a SQL database. There's a number of other customers here, big and large, that are using NuoDB in various ways, typically again in a cloud environment or a scale out environment to address their requirements for scale out, continuous availability, as well as disaster recovery. We are located here in Cambridge, Massachusetts, and Boston. We also have offices in Dublin, Ireland, as well as a sales office in London, England. That's our presentation. If you have any questions, feel free to enter them into the questions box, and we will go through some of them.
Thanks, Arif. This is Larita. So we do have a couple of questions that have come in. The first is, why isn't Elastic SQL good for analytics?
That's a great question. It's not the fact that Elastic SQL is not good for analytics. It's the target market that we are going after, which is in the operational database. Analytics requires a different architecture than an operational database. Operational databases are typically row stores. Analytical databases are typically column stores. The reason for the difference is because of how the queries are executed. Operational databases use semantics such as they're doing transactions, singleton inserts, updates, and deletes, which are basically transactions like a credit card swipe or a fraud detection check. Analytics require SQL over a large amount of data, different rows, multiple rows, and they're a lot more efficient when data is organized in a columnar manner. So Elastic SQL for us is an operational workload, and we are suited for specifically for that type of workload.
Great. The second question here is, how easy would it be for me to migrate a MySQL database over to NuoDB?
So as we mentioned earlier, NuoDB is a SQL database. We support standard ANSI SQL 99 specification for SQL. The migrating any database to another database is not easy. There's work involved. Traditionally, it's usually store procedures and other aspects that make it a little more challenging. We've had customers who've migrated their database either from MySQL or SQL Server in a couple of days, and we've got customers who's taken longer because of some of the other pieces that they've got. So, in general, migrating a relational database to NuoDB is generally straightforward. We support the standard semantics, tables, views, store procedures, et cetera, but there's always some nuances between supported SQL syntaxes between the different databases that may make it a little bit more challenging.
Great. Another one is can I write to the same data from multiple transaction engines, or do I need to dedicate TEs to particular types of data?
So NuoDB is a fully distributed, fully replicated environment. We don't require customers to partition or shard their data across TEs. Customers can access all their data from any TE, so there's no need to partition or go to a specific TE to get data. That said, depending on your workload, certain access patterns, it may make sense to sort of logically segregate your application across the TEs such that the data stays in memory, stays in cache, and is hot, and you get a lot of cache hits. We act just like a general cache management system, right? So if I've got cache misses, that means it's going to take a little bit longer to get that data either from another TE that has that data in memory, or the storage manager, which has that data either in its memory or on disk. So from an architectural perspective, there's no reason, there's no need to partition, but from a performance perspective, some of our customers have done logical partitioning across TEs.
Thanks, Sharif. One question here is, how do TE and SM processes communicate with each other?
The TEs and SMs are form a fully peer-to-peer network between them. There's a private network between the TEs and SMs that allow them to communicate both data changes as well as understanding the state of the database across the distributed environment, as well as communication of messages across the environment. So I'm not really sure what the specific how was, but it's really just about a peer-to-peer mesh, a fully connected mesh between the TEs and SMs, such that we're aware of the state of each of the processes, and that any messages can flow to any node at any time.
Another question is, you showed what happens when you lose a TE process. What happens when you lose an SM process?
Yep. In this case, we had two storage managers. Each storage manager had a full copy of the database, so they were fully replicated. So the loss of any one storage manager, again, does not affect the service of the application. As long as you have at least one TE and one SM servicing the database, your application can continue to run. Again, just like a TE, if you lose an SM, you can easily spin up a new storage manager. In this case, once a new storage manager is spun up, it has to replicate the data, so it has to replicate the environment to the new storage manager. So that may take a little bit of time depending on the size of the data, but you can then control how many copies or the case safety of your environment based on the number of storage managers that you're running.
Is it possible to run multiple databases using the same resources?
So that's a good question. In the architecture, so let me just go back to another screen right here, right? And so in this case, this is showing what we call a domain. The domain is made up of 3 brokers, the letter B, 3 TEs, and 2 SMs, right? The 3 TEs and the 2 SMs are dedicated for a specific database. Within NuoDB, you can start up another set of TEs and SMs for another database using the same hardware and the same brokers. So effectively what we can provide is sort of a multi-tenant, multi-database environment such that on the same set of nodes in a cluster or the same set of hardware, I could be running multiple databases. Each TE and SM is dedicated to a set, to one database, but the hardware can be leveraged to use for multiple databases in the same environment.
Great. It looks like that is all the questions that we have for today, Arif. So thanks very much. Oh, wait, one just came in. Is it possible to have one SM process on-premise and another in the cloud?
Good question. Yes, right. So maybe I didn't make this clear, or maybe I didn't even touch on this, right? NuoDB is a fully distributed database. The way we work, it doesn't really matter other than the speed of light. It doesn't matter where the processes are running, and that's for both the TEs and SMs. So you could have a set of TEs and SMs on premises, and you could have a set of TEs and SMs in the cloud, all working together as a single logical database, all active, allowing you to do concurrent read-write workload in both environments.
Do you support OpenShift?
Another good question. Yes, we do, right? So we are working very closely with Red Hat. For those who aren't familiar with OpenShift, OpenShift is a product from Red Hat, and it's their Docker management system. It leverages Kubernetes and a whole bunch of other open source products as part of the solution. So in this demo, we showed you Docker containers. These Docker containers can run both in a Kubernetes environment as well as an OpenShift environment and can be managed. The orchestration of those containers can be managed by OpenShift, and we support that fully. Great.
I think that is the end of the questions, Arif. If anybody has any additional questions that they didn't have the chance to send over, please feel free to email us at info@nuodb.com and we'll respond to them that way. In the meantime, we really appreciate you joining us for this regular monthly webinar, Introduction to NuoDB. If you have colleagues or you want to hear it again, we'll be running it again next month, and we'll continue to do so on a monthly basis. Arif, I want to thank you for your time as well as for the demonstration. Please, I hope that everybody on the call will continue to join us for other future webinars as we continue. Thanks so much for your time today, and have a great day.